Okay, children, let us continue the same topic, acceleration. In the last session, the acceleration is given by the formula A equal to V minus U upon T. This is acceleration. That is change in velocity per unit. And its SI unit, its SI unit is meter per second square. This is the SI unit. And then this acceleration is a vector quantity. Vector quantity. You must know what is vector quantity because in the beginning we discussed about this vector quantity, those quantities which are completely represented by magnitude and direction. That is vector quantity. This acceleration is also a vector quantity. Then what is its direction? If anything is moving along the straight line, its initial velocity is u, final velocity is v. Here it is moving along the same straight line, the direction is not changing. So the direction of acceleration is along the same straight line because its direction is changing. If the object is changing its direction from A to B, it is traveling in this part and then it turns the direction. Now here the direction has changed. Now in this case also the velocity is changing. In this case also velocity changes. Here if we see, the velocity is changing continuously in the same direction. Here the velocity is changed. In this the direction is changing. Now what is the direction of acceleration? The direction of acceleration is always along the direction of change in velocity. In the beginning direction is this one. After that direction is this one. Finally if we see from the initial to final point, and this is the direction coming. So this will be the direction of acceleration, and this shows this is the direction in which the velocity is changed. In the beginning it was horizontally, then it vertical. By taking the resultant, we get the direction of velocity is changing along AC. So this is the direction of acceleration. So simply we can say the direction of acceleration is always along direction of change in velocity. Direction of change in velocity. This is the direction of acceleration. Okay. Now we'll see. The acceleration is having some value. Here if you see, we can have the two situations. Suppose we take a vehicle is going to move along this path, along the straight line. In the beginning we take the vehicle is at rest, so initial velocity is 0. And while traveling in that vehicle, you are seeing that the velocity, the speed is continuously increases. Suppose it is 20, 40, 60, 80, like this, it is increasing. By keeping the same direction, the velocity is the speed is continuously increasing. And in this case, if we want to suppose at this point the velocity is 100, it may be given any unit. Let us say kilometer per hour, whatever it is. Initial velocity is 0, final velocity is 100 km per hour. Velocity continuously increases. Here you see initial velocity and final velocity. And you can see V is greater than U. Final velocity is greater than initial velocity. If this is applied in this formula, then A equal to V minus U upon T. Since V greater than U, we get the positive value, so acceleration is positive. It is positive. If we take the other example, Along the same straight line, if the vehicle is already in motion, when we see the vehicle at this point A, it is already moving. Suppose its speed is 10 meter per second. And from this point, he applied the brake. While we apply the brake, definitely the speed decreases. Suppose the speed is decreasing in this way, 8 meter per second, 6 meter per second, 4 meter per second, 2 meter per second. Like this it is decreasing. Here if we see, here it comes 0 meter per second, that means come to rest. Here if we see, this is the initial velocity in the beginning, we are observing this velocity. Finally its velocity become 0. And you can say this is V is less than U. If V is less than U, from this formula, this value is smaller than this one, we get definitely negative. So acceleration is also negative. Acceleration is positive. If it travels with the same velocity, suppose it is traveling with 10 meter per second, here also 10 meter per second, here also, continuously its value remains constant.